A very warm welcome to SNS, Sweden's leading research-based think tank. My name is Mia Horna-Brandtzen and I'm the CEO of SNS. This year's yearly Tylösand Summit had to be cancelled due to the pandemic, but we are very happy to have this online opportunity to meet you in this way. The overarching theme of the summit is climate change. During a number of different sessions, we will discuss issues like the energy challenge and cost of climate change, policy options, the role of international trade, and also the financial markets in fighting climate change, global leadership and cooperation, and also what we have learned from the pandemic. Apart from being online this year, we also have made one other change. And that is, after the approval of our speakers, we have decided to put our sessions online. And this means that we will not be able to have the Chatham House rules this year. That will not be applicable. But we do, as always at SNS, encourage you to take part in the discussion in the Q&A session, which will be in the last part of our seminar today. You can ask questions both in text through the Q&A function, or put the questions verbally by raise the hand function. And you can text question already now and also during the full presentations. The focus of today is the cost of climate change and the global energy dilemma, and what policy conclusions we can learn and draw from this knowledge. Our keynote speaker is one of the world's most renowned energy and climate economists in the world. He is a professor of economics at University of Chicago and director of Becker Friedman Institute and the Energy Policy Institute. He previously served as the chief economist of President Obama's Council of Economic Advisors, where he co-led the US government's development of the social cost of carbon. So, with further ado, I would like to warmly welcome you and also to hand over to you, Michael Greenstone. The floor is yours.
Thank you very much, Mia. It's my great pleasure to be able to talk to all of you today, although sadly not in person. So I'm going to talk to you, so let me begin by sharing screen. So I want to begin talking, and I will try to be a little provocative and say, I don't think that there is a climate challenge. I actually think there is a global energy challenge, and that global energy challenge includes the climate challenge. So let me begin with this picture, which I think illustrates a lot of the themes that I want to try and convey today. So this is a picture from Beijing, maybe 5 or 6 years ago, and I think it captures what I think of as the 3 legs of the stool of the global energy challenge. So the first leg of the stool is that, and for many of you who've been to Beijing, you'll recognize right away, China is a country on the make. And it was not very long ago that this man in the car was probably on a bike, and it's not going to be very long until the guy on the bike will be in a car. And really the astounding economic growth that China has experienced in the last several decades has been entirely facilitated by access to inexpensive and reliable sources of energy. So leg 1 of the stool is, how can we ensure that societies gain access to inexpensive and reliable sources of energy that can unlock all of the economic well-being that is on display in this picture. The second leg of the stool is also visible. The very same energy that has unlocked all of this economic growth has led to, sources of energy has led to this fog, I guess you would call it, and it's the middle of the day and you can't see the sun. And so the use of the fossil fuels that have unleashed all this economic growth have also caused all this smog and pollution. Our guy on the bike is very aware of it. He has on a mask and goggles. And so the second leg of school is, how can you avoid all the terrible health problems associated with particular forms of energy consumption? And the third leg of the stool, it's not visible, but you know it's there, which is that the same energy that has unlocked this economic growth and has led to all this pollution also involves the release of CO2. And that CO2 is increasing the odds of disruptive climate change. And so my thesis through this talk, which I will try to illustrate in a couple different ways, is that the world is facing this difficult global energy challenge where societies have to find a way to balance these against these and trade off against these three different goals. And those goals are going to be determined by economics, of course, by morals, how people value the present versus the future. And additionally, this challenge is going to look very different, say, in Stockholm than it does in Mumbai. So with that, let me now try to illustrate some of these points. So I structured this so that I'll begin with 7 facts that explain the difficult balance between energy and growth. So the first fact, and many of these facts are not going to be new to you, but I'm going to try to pull them together in a way that will help, ideally help you see the problem in a different way. So energy is critical for growth. So there are few empirical economic relationships that have a tighter relationship than have energy demand on the horizontal axis and GDP on the vertical axis. And here you can see there's few empirical relationships that have such a tight relationship. We just don't have examples of societies achieving high levels of living standards without using lots and lots of energy. So you should think of that as almost a law of nature. The second fact is that energy access is a major problem in many parts of the world. And those parts of the world tend to be very heavily populated. So here's per capita electricity consumption. You can see in the US and Sweden, it's about 13,000 kilowatt hours per person per year. Although the US and Sweden are relatively small relative to some other countries in the world. So here's the state of Bihar. It's in India. It's got about a population of 100 million, 10 times Swedish population, a third of the US population. Their per capita electricity consumption is about 200. So they're off by about a factor of 50 or 65 relative to Sweden and the US. In all of India, it's about 1,000. And you can see I put the populations here. And in all of China, it's maybe like 4,500 kilowatt hours per person. So if you're sitting in these countries, this is not an acceptable state of affairs. And these countries tend to be very heavily populated. Not surprisingly, the third fact follows, and that is the demand is expected to grow rapidly in today's developing countries, not so much in the developed countries. And here you can see data that begins in 1995 and runs to 2050. And you can see that per capita electricity consumption is expected to be, total energy consumption is expected to be about flat in the developed world. This isn't per capita, this is total. And is going to be increasing rapidly in today's emerging countries. In fact, India and China account for about half of global energy demand growth between today and 2050, based on kind of a business as usual scenario. Energy demand in Africa will grow by about 140% between now and 2050. The fourth fact that I want to draw your attention to is that fossil fuels are expected to meet much of this growth. And let me begin by noting there have been incredibly rapid declines in the cost of renewables. That's especially so in solar. The reductions are larger than I think people could have kind of hoped for even 5 or 10 years ago. There have also been some reductions in wind. There have been even faster declines in batteries, which I suspect many of you understand are critical for greening the grid, as well as moving to electric vehicles. Here, the reductions, I think, are really genuinely could not have been predicted a decade ago by reasonable people. Yet, fossil fuels are still projected to be dominant. So today, in total energy consumption, they account for about 80% of total energy demand. In 2040, they're still projected to account for 72%. So that is a decline, but not by terribly much. And so you might ask, why is that the case? Well, the explanation is that fossil fuels remain very inexpensive, and let me illustrate that here in the power sector. So this is for the United States. Obviously, the numbers will vary from place to place. And here I've put the cost of producing a kilowatt hour of electricity using an existing coal plant without environmental controls, a natural gas plant where the US has these bountiful supplies of natural gas currently due to the fracking revolution, a modern coal plant, and then a nuclear plant. And you can see here, just among current baseload technologies, that the fossil fuels tend to be least expensive. Let me now bring in what happens if you had wind onshore, solar onshore. That's obviously going to depend where you are located in the world, and wind offshore. But I've made a little change here. These are not the numbers you might be used to seeing. I've included the requirement that they have backup technologies available so they can operate as frequently as the baseload technologies. And here I'm assuming that the backup is entirely coming from natural gas. This is a way to account for the costs that they socialize onto the grid through their intermittency. And then the last category is, well, suppose we had battery backups. And this is actually probably a generous calculation, in assuming fewer batteries than I expect would be required. And the only point to take away from this is that natural gas still remains the winner here. And while there's been lots of progress in the renewables, they remain out of the money. And if the world is going to decarbonize, it's going to require a conscious decision to buy more expensive sources of electricity, more expensive in the way that we have currently constructed our electricity markets. And I will come back to that. It's also the same story holds in transportation. Here I've made a figure where on the horizontal axis I've got the cost of car batteries, and on the vertical axis I've got the price of oil. And this red line is kind of an equal cost line. Along that line you have pairs of the cost of batteries and the price of oil, where the lifetime costs of running an internal combustion engine and an electric vehicle are essentially equal. And then in the white area, where you have lower prices of petroleum, the internal combustion engines are cheaper, and in the green area, the electric vehicles are cheaper. So let me now just take a look at some pairs of these prices. So if you took the current estimates of what a battery for a car costs, it's about $156 per kilowatt hour. And what price of oil would be required to reach break even? You'd have to have petroleum trading at about $154 per barrel. It's currently about $40. If instead you ask, well, at today's break-even cost, today's oil price is about 40, what would a battery have to be? Well, it would have to be about 75% less expensive than it is. So fossil fuels continue to remain very, very inexpensive. It's also true that fossil fuels remain very abundant. In 1980, we thought that we only had about 30 years left of oil left, 30 years of oil left. Instead, it turns out that if you took the ratio of reserves to production, that's actually grown. Instead of systematically decreasing to zero, it's actually grown to about 50 years. And that's because the energy companies are run by very smart people who figure out new ways all the time to get access to inexpensively access oil. The same is true in natural gas. We just have tons and tons of it. And of course, it's also true in coal. So we're not going to run out of fossil fuels anytime soon. So all of that points to there's a great need for energy consumption, and particularly in today's developing countries. Fossil fuels are poised to continue to play a leading role in supplying that energy. So is there any problem with that? Well, there's two problems, and I'll come back to the second and third legs of the stool. The first problem is that fossil fuels increase pollution, conventional sources of pollution, and that greatly shortens people's lives, causes them to lead shorter and sicker lives. So currently about almost 6 billion people live in parts of the world that exceed the WHO safe guidelines for small particulate matter. Small particulates are the most pernicious form of air pollution. I created something called the Air Quality Life Index, which is based on some work of mine that estimated the life expectancy impacts of exposure to air pollution. I could have spent 30 minutes talking about that, but I will give you a little brief preview of the findings. And this is available on the web, for those of you who are interested. So here's a distribution of particulate matter around the planet. The darker areas are the more polluted. I'll really emphasize to you India and China and parts of sub-Saharan Africa, and there's some parts of Central Europe as well, where there are relatively high concentrations of PM 2.5. And what this tool allows you to do is to convert that into the loss of life expectancy. Or so that is, or put another way, the gain in life expectancy that is available to people and societies who come into compliance from current levels, bring themselves in compliance with WHO guidelines. And here you can see there's parts of India where people are losing on average 5 or 6 years, in China, upwards of 5 or 6 years. In China, I think the average person is losing about 2.5 years of life expectancy due to the levels of air pollution. You can see the US, except for maybe the Central Valley in California, and parts of the Midwest, is relatively clean. Sweden is very clean. And that reflects changes that were made beginning in the 1970s in the United States and many other parts of the world. But this remains a pernicious problem in many parts of the world. So what is striking is when you pull it all together, the average person on the planet, so across people everywhere on the planet, is losing about almost 2 years of life expectancy. That's more than the average person on the planet is losing due to smoking, alcohol and drug use, even car injuries, HIV/AIDS, on and on and on. And so I think particulate pollution is not adequately recognized as the social threat it really is. So that's the second leg of the stool. The use of fossil fuels involves these really pernicious impacts on human well-being. Now, the third leg of the stool is that fossil fuels are causing climate change, and its projected impacts are large and quite heterogeneous. And I want to return to the heterogeneous, and that's a point I'll try to emphasize. So this is, and I apologize, this is in Fahrenheit. I'm going to try and have some slides in a minute where we have some Celsius conversions. But this is and you'll see in a moment why I chose India. This is the distribution of average daily temperatures in India. So it's not the high, it's not the low, but it's the average of the high and low. And you can see that the average person in India faces about 60 days a year where the temperature is between 79 and 81. And there are a lot of hot days in India, certainly relative to Sweden and the United States. But what I want to show you is what is projected to happen by the end of the century. And this is a distribution of days that's projected at the end of the century. And I just want to underscore the increase in these days. And so people talk about changes in global mean temperature. What I think is really important is the number of very hot days. These are the days where health problems are concentrated. These are the days where there's crop failure and a whole series of other unfortunate things that compromise people's ability to live well. And so now I'm going to try and illustrate that, drawing on some work that I'm doing with some colleagues. And let me just begin by showing you this exercise, so 35C is greater than 95. This exercise is a comparison of what happens to the annual mortality rate if you take a day in the very temperate range of 70 to 74, which is 21 to 23C, and swap it for one of these hot days, which there's going to be many more with climate change. And this is in the United States. And you can see that there's an increase in the annual mortality rate. Let's set aside the exact magnitude for a moment. But now I'm going to do something tricky. I'm going to expand the vertical axis, but keep this same blue line. So this is the same blue line, but I've just expanded the vertical axis. Now, the reason that I've expanded the vertical axis is that I want to fit the same response function, except to do it for India. And so that's what we have here. And so now in India, by contrast, if you take a day that's in the 70 to 74 range and swap it for a day that's greater than 95 or greater than 35C, you can see the impacts of mortality are about 20 times larger than they are in the US. And I want to underscore, if you're in India, this is like a totally unacceptable way to live. You're thinking to yourself, why there's all this death and all of this compromised living when these hot days arrive. Why can't I be on the blue line? The blue line, which is, we all have heating and cooling in the United States and Sweden, and what the blue line provides is this safety against the climate. And if you're India, you're going to be laser focused on finding a way to get to the blue line. And that way is going to run through, as I tried to emphasize at the beginning, lots of energy consumption. And that energy consumption is the best way to get the economic growth that can bring you to the blue line. I'll just briefly show you that globally, the impacts of climate change on mortality are expected to be quite large. In 2100, the impacts of temperature-related mortality are about as large as the global burden today of cancer and infectious diseases, somewhere in between those two, maybe not quite as big as cardiovascular. So it's dropping this additional source of mortality into our lives. This is in 2100. It's also, the impacts are expected to be very, very heterogeneous. And you can see so I tried to switch this for Stockholm, and I apologize for having Oslo up, but the result, I wasn't able to get the right data, but the picture's roughly the same. There are parts of the world that are going to benefit, and that's because these parts of the world are getting rid of the cold days, which are very damaging, and not getting such a large increase in the hot days that are damaging. But there are also large parts of the world where, and especially in Africa and India and some places in China, and Accra is a really terrific example of a place that's deeply exposed to large increases in mortality by the end of the century. And so this adds to the challenge of this global energy challenge, which is that the impacts of climate change are not going to be distributed equally, and yet we kind of need the world to see the climate problem the same. So let me now just give a few facts on the climate, how challenging the climate challenge is, and how the global energy challenge makes it harder. So just to level set, if we were on, so this is annual emissions of greenhouse gases. If we were on a business as usual scenario, this is kind of how emissions are expected to unfold, the red line, over the course of the century. The scientists recommend a 2-degree pathway. You can see that's a very sharp decline. Some scientists recommend a 1.5 degrees pathway. And then if you were to kind of take the Paris Agreement and project it forward, which, there's some guesses there because the Paris Agreement doesn't go to the end of the century, you would end up with something in the middle. So I would view the Paris Agreement as kind of a start, but I really want to dig in for a minute on, what would a 2-degree pathway look like? And, we're effectively here. And so to reach 2 degrees, it would require, unprecedented reductions in greenhouse gas emissions. And I think this chart illustrates that very nicely. So let me just now turn to, so the challenge is great, but let me now turn to why it's going to be so complicated politically. So if we just take a look at annual greenhouse gas emissions by region, this is in 2020, the US probably accounts for 15%, other developed countries maybe 25%, and then developing countries are about the remaining 60%. If you zoom forward to 2050, you can see the US and developed countries' share is projected to go down. And if you go to the end of the century, that kind of holds. And so through the end of the 21st century, 73% of annual emissions are projected to come from today's developing countries. So without saying who's going to pay for it, what is absolutely clear is that the raw arithmetic of the climate challenge requires finding reductions in the very countries, and this is where the global energy challenge comes in the very countries that are so desperate to increase their energy consumption. And so there's just no getting around, no matter what other developed countries in the US do, to avoid disruptive climate change, it's going to require large reductions in today's developing countries. Okay, so my friends tease me that part of the talk can be a little dark. And so now let me turn to what I think are three key solutions that can help to address or confront the energy challenge. So the first is energy markets are set up in most of the world in such a way to deliver this outcome. And that's because energy is not priced at its full social cost. It usually just reflects private costs. And it doesn't account for either the pollution or the CO2 or climate change damages associated with its consumption. So we looked at this a couple minutes ago. Let me just remind you, in the United States, this is where I have data from, the fossil fuels look like winners, and because they are able to provide electricity much less expensively. Now, however, what I'm going to do with this exercise is I'm going to start adding in these external costs of pollution. So this would be the health costs from particulates pollution, and then the green bar is going to be greenhouse gases or the climate damages. So when you add in the pollution impacts, the story starts to change. Whereas it had looked like coal would still a reasonable choice in some parts of the world. Now it's very difficult to make the case for using coal. You can see that some of the renewables begin to look like they're closer to being in the money. Natural gas is very clean for regular pollution, so its price doesn't go up very much. And now what I want to turn to is, well, how can we figure out the impacts, climate impacts of fossil fuels? And that's an area that I've been doing a lot of research, and it's an area where I help lead the US government setting the social cost of carbon. And so what is the social cost of carbon? I like to joke that it's the most important number that you probably never heard about. It is the monetary value of the damages from emitting an incremental ton of CO2 into the atmosphere. So in principle, it should reflect the full cost to society, the impacts associated with a warming world, including through human health, changes in agriculture and labor productivity, property damage from flood risk, on and on and on. So to economists, the social cost of carbon is exactly the negative externality, in our terrible language, associated with emitting 1 ton of CO2. To policymakers, the social cost of carbon is a critical input for developing effective and efficient climate policies, because it gives you exactly the adder that should be put on to the use of fossil fuels, so to determine an optimal carbon tax. And it can be fed directly into cost-benefit analysis of regulatory actions that limit greenhouse gas emissions. So in short, the SEC eliminates a lot of guesswork. And the Obama administration set the 2020 value of the social cost of carbon at $51. Based on what was then the frontier science. And I will come to it, the Trump administration kind of moved away from science, might be a gentle way to say it, and set a much lower number. But let me show you how it can be so useful. Here's a rule that was to reduce greenhouse gas emissions in trucks in the United States. It had social benefits of about $280 billion, costs of $345 billion, and it looked like a bad idea because it had negative net benefits. But it only looked at a bad idea if you didn't value the greenhouse gas reductions. If you valued the greenhouse gas reductions, you could see, well, there would be an additional benefit of about $177 billion. And indeed, this rule was societally positive if you included the greenhouse gas emissions and the monetized value. And so that's how the social cost of carbon can be used, because it just provides a way to turn the reductions of CO2 into monetary terms. So I also want to underscore that there has been a lot of scientific progress on the social cost of carbon. Since it was originally set, I helped originally set it with the Obama administration in 2010. And in particular, the models, or the integrated assessment models that were used to set it, came from a period where we didn't have very powerful computers. We didn't have a lot of data. And so the damage functions, which are represented here, were all, kind of terrific estimates, but really assumptions, assumption driven, of what the relationship was between global mean temperatures and damages. And this was reflected in the National Academies of Science report released in 2017 that said that these damage functions don't reflect advances in science and economics. So what I've been doing is leading something called the Climate Impact Lab, where it's a team of economists, climate scientists, computer scientists, data experts that is trying to build the first empirically founded estimates of climate damages, including of the social cost of carbon. So we're using projections of temperature, precipitation, sea level rise, and humidity from frontier climate models. We're collected historical real-world data to develop rigorous projections of economic impacts. Importantly, we're gaining much greater geographic resolution. The existing models really treated the world as, in the best case, 16 regions, sometimes 8 regions. We're projecting damages for 25,000 separate parts of the world, and then we're going to monetize that and produce what will be the first empirically derived estimate of social cost of carbon. I could probably talk for 4 hours about this or longer, but Mia has assured me that that would not be appropriate. So what I thought I would do is just give you a little flavor of of how this works. And so this is, I want you to imagine the release of 1 extra ton of CO2 into the atmosphere. And I want to trace out what the impacts will be on mortality around the world. So the first thing you got to do is you got to convert the change of CO2 into CO2 emissions into CO2 concentrations. And you can see it shoots up, matching that emissions. It shoots down for a while as the ocean sucks in a lot of that CO2 and then starts to release it. Here is the change in temperature from that 1 additional ton of CO2. And then what this research provides is the time path of, in monetary terms here, the present value of the damages associated with changes in mortality. And so you can see at first, actually, there's some benefits as we get rid of cold days, but then you have this long tail of damages from the release of that additional ton of CO2. And so all in all, this new research finds that an additional ton of CO2 it causes about $37 of marginal damages. It's worth noting that if you were to go back to the Obama social cost of carbon, they had projected only about $2 of mortality damages. So this new empirically founded approach is leading, in the case of mortality, to much larger estimates of the damages from climate change. Just to put these numbers into perspective, the total Obama number was about $50. The Trump number was $3 or $4. You might want to compare it to carbon prices in different parts of the world. In the EU ETS, it's about $30. Sweden has a very high carbon tax. and the overall global price in the world is probably about $2.50. So now coming back to pricing fossil fuels correctly, once you add in the climate charge, you can see that the game is completely changed. It is true natural gas would still be important in the United States, but all these other technologies now look much closer to being in the money. So the first policy lesson is that fossil fuels are mispriced, and we are devising energy markets around the world in such a way that they deliver the continued use of fossil fuels, and it does not have to be that way. The second key solution is to underscore how critical it is to invest in innovation. And here's just one thing I'll point to. We continue to have great reticence around the world to use markets to unleash innovation. Here's an example of a high-tech machine that can pull carbon out of the atmosphere. There is no market for this machine, and so it's very hard for developers to get venture capital funding and to start companies. But we should, I would encourage the world to think about ways of developing, allowing markets to generate more innovation. Given the scale of the global energy challenge, I think it's not good that we are devoting, by historical standards, a relatively low level of money to energy R&D. And so that's the second policy suggestion or solution. And then the third, which I've tried to emphasize, is how critical it is to foster international cooperation. Sweden's announcement that they would go carbon neutral by 2045, 3 years ago, was very dramatic. It has helped set off reductions, promised reductions from the EU, in China, Canada, and Japan, and continued use of international cooperation and international agreements. Here's just a list of potential ways are important to generate reductions. But I just want to emphasize it's going to be critical to find a way to get developing countries to see it as in their own interest, which, given the global energy challenge, is no small task. And I know I'm running out of time. I thought people might be interested in a little bonus update. The U.S. government has changed, and the Biden administration is coming. It's probably worth putting in perspective what can be done with and without control of the Senate. The things on the left are all things that the Biden administration would have very little difficulty doing, even without control of the Senate. The things on the right are probably going to require Democrats to take control of the Senate. They include 100% clean energy by 2035, going to net zero by 2050. All of that will be very challenging without Senate. So I'll just leave you with a picture of Georgia, where there are two runoff elections, where the Democrats are perversely on the right and the Republicans are on the left. And if the Democrats take both, then they would take control of the Senate. And I think there would be an opportunity to engage in much more ambitious climate policy. So with that, let me just turn back to where I began. Here's the picture of our guy on the bike. And I think too often in the developed world, we think that the only thing that matters is getting, or the most important thing that matters is getting our own houses in order, and that's certainly important. But there has to be, the climate challenge will not work. We will not be able to address the climate challenge unless we can see it from the perspective that other parts of the world see. And for them, this trade-off between economic growth and climate and pollution binds in a much sharper way. So thank you very much, and I look forward to the discussion.
Michael, thank you so much for that rich overview of all the different aspects of the issues we're talking about today. I really thank you for that, and looking forward to have you back in the panel discussions. Now I would like to give the floor to John Hassler to give a comment. John is the professor of economics at the Institute for International Economic Studies at Stockholm University. You serve as a member of the Committee for Sveriges Riksbank's Prize in Economic Sciences in the memory of Alfred Nobel. You were previously the chair of the Swedish Fiscal Policy Council, as well as chair of and co-author of the SNS Economic Policy Council Report 2020, Swedish Policy for Global Climate. A warm welcome, John. The floor is yours.
Thank you very much. It's great to be able to participate in this. Of course, we all would have hoped to be in Tylösand. I love it there, and I hope and also think that we're going to be able to make it next year. So I'm going to give a perhaps slightly different perspective to Michael's. In the end, I think we're going to agree, and I very much agree on Michael's last point, that we need to think about the climate challenge as a global problem, and in particular see it from the point of view of how China can be convinced to get rid of their addiction to coal. So let me start with talking about something that you often hear, namely that growth is the problem. Growth in the economy, growth in population, and so on. And you often hear a narrative saying that oil and energy is necessary for growth. And that implies then that to stop global warming, also growth must stop. And I think that's clearly wrong. And I think one of the reasons for why this idea has caught on in a bit wider circles than you might have expected is that in the short run, the economy uses different production factors, and including energy and oil, in almost fixed proportions. But that's not the case in the long run. And so I'm challenging a bit Michael's point that there is a natural law requiring and ever increasing. I'm exaggerating a little bit of what you said, Michael, but that there is a natural law saying that we must increase energy use, and I'm not sure that that's true. So let me give a few figures here, at least giving you some ideas about how I think about it. So this is the price of energy in the US, the fixed price, so in fixed dollars from 1970 up until 2019, and for most of this time, including all of this time, this is dominated by the price of fossil fuel, because that's the dominating source of energy in the US. So what you see is that we have had quite a variable change of prices, and over this time, we all know that they went up in the 70s and then fell down and then came back up in the beginning of the 2000s. And if you now look at energy expenditures as a share of GDP, you see that curve really follows very closely. The correlation is almost perfect in the sense that when energy prices go up, you spend much more on them as a share of GDP. And this, of course, reflects that in the short run, there's not much you can do. You have to continue to consume, and if the price goes up, you're going to spend more of it. Now let's look at the trends instead. And over this period, from 1970 and up, and onwards, there's been a trend-wise increase in the energy price, but that actually has went on at the same time as the total share of GDP that we spend on energy has been falling quite substantially, not year by year, but if you accumulate it over these 50 years, it's a substantial change. And that suggests that in the longer run, there is a flexibility. We have done some work, and with me, I mean me, Per Krusell, and Conny Olofsson have been trying to model this and estimate it from the way at least the US economy works. And here, this graph is from a working paper that's been around for quite some time now, but the latest version is from this year. And what we do here is that we estimate something that you can call the energy saving technology. So how, in a sense, how efficiently we use energy, how much GDP we can easily, you can think of it as kind of how much GDP we can produce per unit of energy. It's a little bit more complicated, but that's kind of captures the idea of it. And what you can see here is that if you go further back in time, so from the 50s, and onwards, we didn't really have any change in energy efficiency at all in the US economy. But exactly at the first oil shock, there was a trend break. So after that, there's been a substantial increase in the energy efficiency. And we use this this relationship in the long run growth model, showing that actually even in the unfortunate case that we can't expand our energy use, we actually have to reduce it. Growth is possible because of this, what we call endogenous technology. When energy becomes more scarce, its price goes up. And that triggers a lot of technological development that makes you use energy in a more efficient way. I also wanted to show this example of that emission trends can be broken. So this is taken from the report that Mia was talking about from the SNS Konjunkturråd. And this is emissions of CO2 in a very long time perspective. And you see that in the 70s, at the time of the oil price shock, we managed to break our trend towards increasing emissions. Of course, that had a lot to do with the expansion of nuclear power, but it shows that something can be done. So that leads me to my first set of conclusion, and that is that the economy is quite flexible in the long run. So I talked about energy here, but this is kind of fairly true for all inputs in the production. Land, man-hour, materials, energy, oil. In the short run, they are required in almost fixed proportions, but if they are becoming more expensive, technologies to save on them are developed. And that creates a much less clear long-run relation between the use of these resources and growth. And we know that, of course, that for a quite long time, growth have been possible despite that we use much fewer man-hours now than we used 100 years ago. And this idea that when something becomes expensive, like labor, you develop technologies for using it more efficiently, that extends, according to our reasoning, also to energy. But the price on emissions is necessary, and it is efficient, and it allows the power of markets to be used to halt climate change. And there, I'm fairly sure that Mike and I are in agreement. So the second set of conclusions I wanted to talk about starts with the fact that there is an enormous uncertainty regarding these issues. There's no question about that the emission of greenhouse gases is affecting the global energy balance. So the balance between incoming energy from the sun and energy flowing out in the form of heat waves and reflection to the rest of the universe. And that more greenhouse gases changes this balance that we know since more than 100 years ago. But there are feedback mechanisms, and in particular cloud formations, that we don't really know how they are affecting the overall energy balance. Are they strengthening or weakening the direct effect coming from greenhouse gases? And if you look at what IPCC says, they say that global warming is in their models at least fairly proportional to accumulated emissions, and they provide a likely interval, saying that the global mean temperature increases by 0.8 to 2.5 degrees per trillion ton carbon of emissions, and that's in a very wide range. And you can understand that by noting that we have now emitted around 0.6 trillion tons, so 600 billion tons, and if we are in the lower range here, that's going to produce a global warming of 0.5 degree, and if we are in the upper end of this range, 1.5 degrees, and if we are in the lower range, then we can continue with business as usual for a couple of 100 years without even breaking the 2 degree limit. But as I said, if we are in the upper part of the range, it's already too late, at least, to stay below 1.5 degrees. And I very much appreciate Michael's work on expanding our knowledge about the consequences for human welfare of global warming. And I also agree that maybe the most problematic consequence is that we're going to see in some parts of the world extended periods when you have extreme heat waves where the temperature is so large, so you can't be outdoors more than a couple of hours without actually dying from heat distress. And this is because of a combination of heat and humidity that we haven't really seen, not even in the Death Valley in the past. But my point here is that given this enormous uncertainty, kind of standard cost-benefit calculations aiming for an optimal tax or even for a fairly exact value of the social cost of carbon, I don't think that's very informative for policy. In a sense, there's so large uncertainty. So it's going to be, whatever we do, we're going to kind of, in a sense, regret it afterwards. That we could have done better if we knew exactly how sensitive the climate was to emissions and how sensitive human welfare is to climate change. So policy errors cannot be avoided. I think we can nevertheless use our models to say something about these errors, and that we have done in some work with the same guys, Per Krusell and Conny Olofsson, in a paper published a couple of years ago. And here we calculated in our integrated assessment model the consequences of doing two types of policy mistakes. So one is kind of hoping for the best, that climate sensitivity is low, it's not going to be difficult to adapt to changing climate, and put in place a policy that's right then, which is more or less doing nothing, at least not in the short run. And then policy mistake is that then you realize much later, say 50 years later, that you should have had a highly ambitious climate policy, because it turned out that the climate sensitivity was high and it was quite difficult to deal with the consequences of climate change. Then this curve gives you the global welfare costs as share of GDP of that policy mistake, hoping for the best, and it turns out that that's was not what you should have done. The other policy mistake is kind of instead saying that we must be quite ambitious here and introducing a global carbon price, which is high, substantially higher than any of the numbers that Michael put up. But then it turns out that was not necessary. The climate sensitivity in the end wasn't very high, and it was fairly easy to adapt. Then you see that the welfare consequences or the cost of that policy mistake are much, much lower. But it gets, in a sense, even worse than that when you talk about uncertainty. You could think that, I mean, these here, what we did in the previous graph was kind of relatively not taking into account the more speculative consequences of emissions, and you can think of a worst case scenario. If Rockström is right, he's probably not going to be right, but you can't rule that out. And in such a case, I think even a carbon price in the order of the numbers that I was talking about before, that they are being substantially higher than Michael's, even that is probably not going to be enough. So we can have, fast arriving tipping points of the sort Rockström talked about. We can have a climate sensitivity that's even substantially larger than the 2.5 degrees per trillion tons of carbon. It can be that it gets much more difficult than we expected to deal with climate change, and of course policy cooperation may break down. And my conclusion then is that in addition to an ambitious climate policy, we need a plan B. So this is the second set of conclusions that are derived from the fact that we are quite uncertain about these issues. And that is that we need to look for robust rather than optimal policies that give acceptable outcomes also under many possible scenarios. And a CO2 tax in the order of the Swedish, or perhaps a little higher, is such a robust policy. It works like an insurance. It's not too costly if it's not needed, but it's very good to have in place if bad things happen. But we also need a plan B. And there I argue that there are possibilities, and they are not necessarily expensive, and planning should start on that. I'm not an expert on these kinds of things, but together with Christer Fuglesang, who is an expert on these things, I've written a few things, and he suggests that we should start thinking about many plan Bs, and one of them being having great parasols up in space. And we would need to compensate for the CO2 that we expect in this century to send up parasols with an area about 3 times as large as Sweden. And that would cost maybe $1 trillion or two. But that's and actually when we first started talking about that, he called me up and said, John, is $1 trillion is that a lot? And I told him that it's not actually in these circumstances. It's about as much as we have in the Norwegian oil fund. Relative to GDP is about as much as US spent on the Apollo project. So this is certainly economically feasible, even though it might seem like a bit of a science fiction now. Third set of conclusions is that we need a global solution. It becomes very expensive if not all parts of the world participates, and in particular China, and that was emphasized by Michael, must be in. And we used our model to see how much the rest of the world needs to do if China doesn't fulfill the promises that they now have pledged. And what turns out is that in the rest of the world, we need to have a 20 times higher carbon price if we need to compensate for that China is not in. And this is the welfare costs that are imposed on the rest of these large regions, EU, US, Africa, India, and other regions of the world if China doesn't participate. And you see that they do gain, and that is because they don't have to take the cost, but they will see about the same changes in the climate anyway. But the rest of the world needs to take on much more cost and so large that it's not going to be possible. So that's the third set of conclusions, that we must have a global aim for the climate policies, and cleaning one's own backyard is not going to be enough. Moving emissions out of a jurisdiction is meaningless at best. And I also argue that in many cases local emission targets are highly questionable. I think also that we should only subsidize development of technologies if they are scalable and can be used globally. So I'm afraid of mixing climate policies and industrial policy. I think, though, that the plan for climate neutral EU is a showcase for the rest of the world, and EU ETS is key here. And I noticed that the EU Commission plans now to include both heating and transportation in the EU ETS, and that's going to be very good, I think, for the climate. But of course, it's going to make the Swedish goals, like the transport sector goal for 2030, obsolete. So I'm going to end there with my three conclusions. A price on emissions is the efficient way to deal with climate change, and a high emission price, like the Swedish EU tax globally, is a robust policy, but we also need a plan B, and local policies must be devised with a global aim. Thank you.
Thank you very much, John, also for those very interesting remarks, and we will come back to those in shortly. Because now I would like to invite our third speaker, Lena Höök, and also ask Michael to come back into the picture again. Lena is the Senior Vice President Sustainability at Skanska Group, and she has previously served as Head of Sustainability at Skandia Norden. She's the chair of the Sustainability Committee at ICC Sweden and serves on the board of Swedish International Development Cooperation Agency, SIDA. A warm welcome to you, Lena. I hope we will see you soon here.
And thank you, Mia. I think I will have help from your technical people regarding getting my video started. I have started it from my part.
Shall we do like this, that they work on that and you still start your talk? Could that be okay, Lena?
Yeah, that works fine for me. So I am most honored to be part of such a distinguished crowd, both among other panelists as well as leaders from the Swedish society and business. I guess I will bring a bit of a boots on the ground perspective from the lenses of construction and development here. It is an industry with a quite heavy impact on climate. The built environment and construction stands for approximately 39% of energy-related carbon emissions, according to World Green Building Council, when you take into account the life cycle perspective. It also stands for about 30% of global resource consumption. And just to give a perspective here, the most common used construction material is cement. It stands for 8% of the global carbon emissions. So taking this into account, it is an industry with quite a large impact, and also Michael pointed that out. It is also to consider that there is growing urban population. So another 2.5 billion people are expected to live in urban areas, and the building stock to almost double in size by 2050. This is equivalent to construction of a city the size of Stockholm every week, or construction of a city the size of New York every month from now until 2050. So the industry and the built environment is part of the problem, but may also be part of the solution. And it's not just nations committing to Paris Agreement, it's also cities that are doing these. And I would like to put forth the C40, a network of the 100 greatest cities on Earth, and or largest at least, like Paris, New York, Hong Kong, Johannesburg, Sao Paulo, Stockholm, amongst others. They stand for about a quarter of the global GDP derives from these cities, and they have set out to follow the Paris Agreement in order to build greener, healthier, and resilient buildings and infrastructure. And just to understand what's happening, the shift taking place, we were talking about, or both previous speakers were talking about the electrical, the needed for renewables. The shift taking place in the past 10 years, these cities has gone from less than 100 electrical buses to today have about 66,000 electrical buses up on their streets. They have now committed to build back better on recovery packages. as well as to make sure that they are being part of a greener transformation. I'm sorry, I'm stumbling here. It's my video, it's still not working. These cities also feel the impact of climate change. It is, of course, air pollution, heat waves, storms, and floodings. And yet again, to give a perspective, the insurance costs related to extreme weather events has tripled the past 30 years. And that's just the ones that are, of course, being the insured environment. I'm just setting forth some of those examples, what the built environment, what cities, as well as a great need of the energy consumptions are relating to. As for Skanska, we, as many other companies, have set out a climate target to reach net zero by 2045. We also include our value chain. We do acknowledge it's a shift towards renewable energy and fuel, careful use of resources and circular solutions being needed, but also innovation and partnership for innovation is needed to be done. When we're looking into this, it's not just about using known technology, but it's also to make sure that this shift is taking place. For example, we've been driving innovation together with Volvo to electrify and optimize a quarry, where we're able to reduce carbon with 98% and as well as energy costs with 70%. That's just one example. And maybe a greater example, and just to understand the importance of this, there's about 50,000 quarries around the world. When we in Sweden or any other country set forth for innovations, they may be scalable also elsewhere. And that's, of course, an utter aim for us to be part of that process. As well, adding on the energy need for buildings and the possibility with energy plus buildings, that is houses that are actually producing more energy than is used during their lifespan. What is then happening for Skanska, we have been doing a concept that we call the powerhouse, which by the World Economic Forum is recognized as the most advanced energy plus house in the world. It is part of the very northern of Norway. But it's not just for the heating conditions that we're talking about. I think Michael also pointed out that it's quite challenging when it comes to humidity and the hot climates. And we have been building in another hot topic, at least, Georgia, also known for quite hot and humid climate, where we'll be building a living building challenge, also an energy plus building, producing its own energy. So these kinds of solutions and innovations, I think there are plenty of those kinds of technological advancements happening right now on the ground. A lot of industries have a lot of those solutions and technological advancements happening right now. But key here, and I think it's been lifted before, it's about cracking the business case. How to make it scalable, how to make it achievable, and how to also make it accessible all over the world. And that's something to talk about. It's not just about the people with the boots on the ground finding the solutions. It's also about the people, specialists, understand and analyze, making sure the measurements and follow-up of performance is valid, as well, of course, the people being the very leaders, having a clear attention. And by that, I would like to thank SNS, making sure that this topic is being brought to quite a few leaders' attention by this.
Thank you, Lena. And I do hope you come back in the picture. I think there was some message sent to you while you were talking, and that might help you. We will see. We hope for that. So thank you very much. And now I would like to start our panel discussion. First of all, Michael, please also you come in here. And I was going to ask one question which related to some of the issues that came up, and that is the flexibility of the economy on a long term and the transition path that is necessary. What is your view on that? And also this issue.
Oh, sorry, go ahead.
Yes, and also the issue of uncertainty. What is your view on that, given also your models that you have been presented?
Yeah, so I think John and I probably agree about most things. With respect to the economy's ability and capability of adjusting and changing the factors of shares of factors of production. There's no doubt that that's true. That graph he put up is truly astounding, how there was no real innovation in energy until the oil shocks. But I don't think, where maybe there's a slight disagreement, I don't think that should lead one to think that taxing energy or putting a price on emissions has no costs. That, I think I want to keep coming back to, we can't view the problem just from the Swedish or the United States perspective, but you have to see the problem from the perspective of India or China or other developing countries, where those costs, given their level of income, their current level of income, are going to appear much larger than they appear to us. So I think the case for pricing emissions is very strong, but there are real costs, and the way that they're going to look outside of the developed countries is very different than they look inside. And then, John's point about the uncertainty is real about climate. He points to the equilibrium climate sensitivity. I think there are other sources of uncertainty, certainly including there's a lot of uncertainty about what the economic impacts would be. I think actually we have a slightly different viewpoint in that I think it's very straightforward to know how to value that uncertainty. We've developed lots of techniques. We can infer it from how people buy insurance policies for fires, for their house, or auto insurance and things like that. And that our estimates of the climate damages should value that uncertainty directly. And that's something that was not true in the US government social cost of carbon, but it's something I'm working on and encouraging the US government to bring into their estimates. There just wasn't an appetite for that originally in 2010. And that's the way I would think about it, is kind of a certainty equivalent social cost of carbon.
Thank you. Could I also ask you on the issue of solutions? You mentioned 3 key solutions to price the carbon and to promote innovation and also to further international cooperation. Which of those would be the most promising one? I mean, we all know that the price of carbon pricing is not on the negotiating table. We know that international cooperation has been difficult for some years, to put it mildly.
Yeah.
And also when it comes to innovation, that the investment going into it is not increasing enough. What would it take to get these things start working?
Yeah. So, look, I think the core problem, which I think drives the global energy challenge, is that the fossil fuels, ignoring their externalities, ignoring their climate impacts, ignoring their health impacts from air pollution, are cheaper. And that core problem won't go away until they're no longer cheaper. And so I think really spending a ton of resources on trying to close that delta or that gap is critical. And then I think willingness to explore a price on emissions, which would be pretty small if you were able to close that gap, and willingness for international cooperation will all kind of melt away. The problems with them will all kind of melt away. And so, the core problem is that we don't have enough inexpensive ways to deal with the climate challenge. And anything we can do to foster that would be enormously productive. I should say one other thing. We always talk about technical innovation, and that's very important. I think there's lots of room for policy innovation and finding ways to make it easier for today's developing countries to engage in robust policy, providing incentives for them to do so. I think that's another promising avenue.
Thank you, Michael. Turning to that last issue you mentioned, Lena, you are on the board of SIDA, the Swedish Development Cooperation Agency. what is your viewpoint, and also giving your experience from where you are now at Skanska? What can be done to promote climate-friendly policies while accepting the need for energy increase, availability increase in developing countries?
Well, SIDA and other aid organizations can be part of helping out that transformation. And one thing is to actually be accessible when it comes to funding of capital, of course, and taking down the risk for those that want to invest in certain kinds, for example, renewable energy sources. We also see that there's a great need when it comes to build infrastructure. And that is, of course, infrastructure related to energy, but also water and sanitation, as well as transportation. So when it comes to all of those aspects for different kind of aid organizations to cooperate with business and policymakers and countries in order to make a long-term decision making and making that easier, and maybe also being the part that are giving, for example, as SIDA does, giving grants and guarantees when it comes to actually taking those long-term and times maybe riskier or a bit more advanced as well as more costly when it comes to go for more sustainable solutions.
Thank you. I would like to bring in a question from the audience, and also tell you that you're welcome to put more questions into the discussion. This is a question from Christian Danielsson, head of the EU Commission here in Stockholm, Sweden. And he asks, how do you assess the importance of the taxonomy? And as you might know, the EU taxonomy is a tool to help investors, companies, issuers, and project promoters navigate the transition to a low carbon, resilient, and resource efficient economy. This is a text taken from the Commission's website. In connection to that, and I would like to ask John on another EU proposal, which is is being discussed, the carbon border taxes. Would that be an issue that could, something that could help getting developing countries and others to be promoting more climate-friendly policies? John.
Yeah, first on the taxonomy, I'm not an expert on that, but I'm a little bit worried that it's gonna work in possibly the wrong direction. It depends a little bit on how this is going to be used. My view is that what we need to do is an orderly transition to climate neutrality, and that implies that for a couple of decades there's going to be a lot of fossil used, and there's going to be a need for good owners of these fossil reserves and the uses of these fossil fuels. So if the taxonomy leads to that kind of socially responsible investors leave that area to those who are not responsible, then I think then it's gonna lead to bad outcomes. But of course that's not necessary. You should know what you are investing in. But there doesn't seem to be kind of a. I don't see that the problem with financing the transition is that there is a lack of interest in financing it. It's rather that you need to have the carbon pricing in place, and that I think works fine now in EU. I'm pretty happy with the way EU works. But of course, one problem with the EU. With the EU regulation is the one that you took up, namely that there can be leakage. Firms that develop new technologies might be outcompeted by exporters from countries where you don't have any carbon pricing, and that's, I think, is a real problem. And I think the EU Commission approach here, namely to kind of at least in the beginning, think of this as in a case-by-case way, so that if, for example, Northvolt, which is going to produce a lot of batteries with clean fossil-free electricity in Sweden, if they risk being outcompeted by battery producers using coal energy, coal-based electricity, then you need to act. But this very nice idea that has been developed by Nordhaus and others of having kind of a total border adjustment, namely kind of calculating the carbon content in everything that crosses the border from outside to EU, and then calculating how much that should have been taxed and taxing the difference. I think that's going to be too complicated and not going to work. But in some particular areas where it's necessary to protect the possibilities of developing green alternatives in EU, I think we need to have some sort of that.
Michael, it would be very interesting to hear your view on that European idea from a US perspective.
Look, I think we should be flooding the zone with sticks and carrots to engender climate policy taking place around the world. John is right. The implementation of border adjustments can be very, very complicated. It seems like an excellent employment policy for lawyers. On the other hand, I think we just absolutely have to provide incentives, both, as I said, sticks and carrots, to take up policies around the world. Look, one obvious solution would be for the EU and the United States to ship tons and tons of money to today's developing countries to put in low carbon technologies. If it's worth so much to us, we should be willing to pay for it. I think it's almost impossible to imagine, I don't know Swedish politics, it's almost impossible to imagine anyone running for Senate in the United States, even say from Illinois or California or Massachusetts, or anyone running for president to run on that policy. So I do think there are lots of opportunities for transferring resources that would facilitate carbon reductions through other mechanisms. And I'll just come back to innovation. I think if we could develop low-cost carbon-free technologies for carbon removal, I had a slide on that, I didn't have time to talk about it, technologies that are successful at inexpensively reducing carbon from the atmosphere or preventing it from going up, those seem like they have very, very high social payoff, particularly, John pointed to how horrible it would be if China doesn't have a price on carbon. China might, but will sub-Saharan Africa? It seems almost impossible to imagine in the near future. Will India? It doesn't seem terribly likely. And so I think we have to be realistic about how we can bring some of these other countries, which are in the future going to be the major emitters, along and be looking for as creative set of sticks and carrots as we can find.
Thank you. Anyone want to comment on the discussion? John?
No, I certainly agree with that we need to have both sticks and carrots, and providing good technologies is one of those. And I'm very much in favor of developing carbon capture and storage technologies. And Sweden and the Nordic countries in general is in a very good situation for doing that. Norway is investing in facilities for taking care of the CO2 that came from their oil, I guess, but they can actually take care of much more than that. And it's interesting actually that technology also puts some sort of benchmark on how costly it can be to remove CO2. And if you use actually the price of CCS technologies in Sweden and transfer that to China, you would realize that to get rid of half of emissions in China, they need to spend 3-4% of their GDP. So it's not enormously costly. And I think there is a possibility to reduce the price of that further, and that would be very, very good.
John, I think you know more about this than I do, but I thought, with the exception of enhanced oil recovery projects, we really didn't have large-scale CCS technologies up and running around the world. And I think it's, given the availability of fossil fuels, the fact that we don't have, demonstrated natural gas or coal projects, CCS projects at large scale up and running, I consider an enormous self-inflicted wound.
Yes, I agree with that. I don't think there is any doubt whether the technology is going to work. But nevertheless, having it in place would be very good. So I think that we should.
I think there's some doubt about how long.
I don't think so. But the total capacities, of course, you can discuss. But what the Norwegians believe is that they can take care of many times the yearly emissions from EU, maybe a couple of decades of emissions. And if you look at IPCC's 1.5 degree scenarios, in some of them they are talking about CCS being used for the equivalent of, say, 15 years of global emissions. So I think there are at least views that this is going to have a very large potential. And if we can start with large-scale operations of it up here, that would be great.
Yeah. Lena, you asked for the floor.
Yeah, I think carbon capture technology, it's really interesting field. However, I think we also need to focus on the possibilities to actually develop and more use the methods we already know how to decrease carbon emissions, as well as how to reduce our need for fossil energy. And just like examples that I put forth there, when it comes to actually energy plus buildings, so all of a sudden start to have actually buildings that are able to charge electrical vehicles, being in a city. These kinds of solutions, they are not science fictions, they are actually for real. They are, however, too little used. And they may also not be at scale as for now. There are too few examples as for now. But we do know the technology. It is a development area. It needs more innovation. For every time something of this is being done as a breakthrough, we actually learn plenty. And that can put us forth even further. So I also want for us to maybe focus on those kind of boots on the ground stuff, a lot of stuff being able to be done, as well as how to be more cautious when it comes to all of our resource usage. I think at times we have just not measured and evaluated the way we're using our resources. Something when we are starting to look into more deeply our carbon emissions, we actually see that when we are tracking carbon, we are also reducing costs. And it's just a sound management, you would say. But of course, taking that into account, there's a lot of more innovation needed to be done, but there are also how to scale up known technologies as well as to build on those for further innovations.
Thank you so much, Lena. I think this has to be our last word at this session. And I really want to stop with saying that the three key solutions that Michael listed, the price of carbon, and also we've talked about internal carbon. We didn't get the time to talk about that. Innovation, both in terms of technology and policy, and also to foster international cooperation, was something that are areas where really we have to work further and where there is some hope. So with those words, I really want to thank you so much for your very rich contribution, and it was a really great honor to have you all here today. Thank you all, and just say that we are going to continue to come back to these issues, and both in terms of meetings, in publications, and also in research projects. And in the coming week, an English translation of the SNS Economic Policy Council report, Swedish Policy for Global Climate, will be published. And on December 8th, we are arranging a meeting in collaboration with IMF and the Institute for International Economic Studies on climate change mitigation. That's chapter 3 in this year's IMF World Economic Outlook that was published earlier this fall. And the remaining sessions of this Tylösand Summit will take place on Wednesday and Thursday. And on Wednesday, we will discuss global leadership and cooperation, some of the issue that was raised here today. And on Thursday, the financial market and also the financial risk and the macroeconomic risk connected to climate change. So you find all the information about our speakers on our website. If you were registered for this session today, you're automatically registered for those sessions coming Wednesday and Thursday. So I hope to see you there, and thank you very much.